All right, we are at section 3.2. That's the textbook page 88 if you're following along. We're talking about linear expressions. And a linear expression is an algebraic expression in which the exponent of the variable is 1. So when it's like negative 4x, the exponent for the x is just a 1. That's why we don't see anything there, because when it's a 1, we don't have to see anything. When it's squared, or when it's to the third power, to the fifth power, these will be nonlinear expressions. We're not going to deal with those this year. We'll just be dealing with linear expressions. And we call them linear because when we graph these, and we will graph these later this year, they form a line. So that's why they're called linear. And what we're going to talk about today is adding linear expressions. So we're going to find the sum. There are two methods. One is the vertical method. I'm not a big fan of the vertical method because it gets a little choppy when we've got some exponents outside or coefficients outside the parentheses. So we're going to look at the horizontal method. So we have this problem right here, negative 4y plus 3 in parentheses. So that's a linear expression. And then we've also got 11y minus 5, another linear expression. And we're going to add those two things up. The first thing you should do is take care of any distributive property that you need to take care of. There is no distributive property on either of these because there's no number right outside the parentheses. There is a 1. You don't see the 1. It's understood to be 1. But when you multiply anything by 1, it just stays the same. So we don't have to distribute anything for these, which means we can just rewrite this with no parentheses. So we took what they had and we just rewrote it with no parentheses. And now we can combine like terms. Negative 4y and 11y are like terms. They're both y terms. So I can combine those. A negative 4 and a positive 11. Different signs, subtract. Keep the sign of the larger absolute value. So it's going to be positive 7y right down here. Positive 7y. Then I have to combine my constant terms. I have a positive 3 and a negative 5. Different signs, subtract, keep it negative this time for the 5, negative 2. 7y, negative 2, or 7y minus 2. That's the answer when we add these linear expressions. Now that was kind of easy, hopefully. This one, a little messier because we do have a coefficient out here. We do have to use the distributive property for this one, for this linear expression. This one just has a 1 out here, so we don't have to worry about it. But this one's got a 2. So the first thing we have to do is distribute that 2. Remember, to distribute it means you multiply it by each term inside. The biggest mistake kids will make is just multiplying it by the first one there. So we distribute that 2. 2 times negative 7.5z, different sign, so negative, remember when we multiply and divide, so negative 15z, negative 15z. 2 times positive 3, positive 6. So now that I've distributed that, this I didn't have to do any distributive, so I just bring that along, 5z minus 2. Now I can combine like terms, negative 15z plus 5z gives me negative 10z, and positive 6, negative 2, combine those to get a positive 4. Negative 10z plus 4 is what we get when we combine those. Okay, so first thing you have to do is take care of distributive property, if there is any, and then you just combine like terms. Here are some problems for you to try. Okay, so for number 1, no distributive property needed here, so I can just combine like terms. So I have an x and a 2x, or if you want to rewrite it, let's rewrite it with no parentheses. It would just be x plus 3 plus 2x minus 1. Now I have an x and a 2x, which gives me, obviously, 3x. Same sign, add and keep. A 3 and a negative 1, which will give me a positive 2. So 3x minus 2. I mean 3x plus 2. Excuse me. Number 2. No distributive property again because there's no number out here, no number out here, except for the understood 1, of course. So I'll rewrite it now with no parentheses. When you're writing your z, make sure it doesn't look like a 2. If your 2's kind of look like that, I highly recommend you go to making your 2's with that little loop at the bottom, because you'll start to make some mistakes, mistaking your z's and 2's for each other. So time to make a switch here. Negative 8z, positive 8z. Those cancel each other out, leaving me with 0z or just 0. Because 0 times anything is 0, I don't have to put anything. Then I've got a positive 4 and a negative 7. That will give me a negative 3 when I combine those. So number 2 is negative 3. For number 3, I do not have a distributive property out here, but I do right here. So I have to take care of that. This here just comes along for the ride, so 4 minus n. And then I have 2 times negative 5n. Different sign, so it'll be a negative. 2 times 5 is 10. Don't forget the n, 10n, negative 10n. And then I have a positive 2 and a positive 3. I multiply those together. Remember, distributive property means multiply. 2 times 3 is 6, positive 6. Well, now I can combine these like terms. I have a positive 4 and a positive 6, so that'll give me a positive 10. I have minus n, remember that means minus 1n, and a minus 10n. Minus 1n and minus 10n, same sign, add and keep, negative 11n. It would be better to rewrite this so the variable term comes first. This is the variable term. Here's my constant term. So when I pull this out front, I don't just pull 11n. It's negative 11n, negative 11n, and then a positive 10. Positive 10. There we go. Negative 11n plus 10. And here is an ugly problem because I'm distributing fractions. And everybody is afraid of fractions. Not me, though, but most people. So 1/2 times w is 1/2 w. 1/2 times negative 6 is negative 3. Plus 1/4 of w is 1/4 w. And 1/4 times 12, or 1/4 of 12, is 3. Positive and a positive. So it's positive, same sign, positive. Well, now I can combine like terms. Oh, I have a negative 3 and a positive 3, so those will cancel out, leaving me with 0 for my constant. And I've got a 1/2 w and a 1/4 w. Well, I do need common denominators, so this would be 2/4 w and 1/4 w, and those leave me with 3/4 w. So the answer for number 4 is 3/4 w. So now we come to subtracting linear expressions. Subtracting linear expressions is not very tough, but a lot of people make it harder than it needs to be. What you need to do is you need to look out front of this one and say, oh, there's nothing to distribute. Cool. And then you look here, and there is something to distribute. Now you might think, well, there's just a 1 out there. I don't have to distribute a 1, but you'd be wrong. If I put a 1 there, what am I actually distributing? A negative 1, because that minus right there makes it a negative 1 I'm distributing. Negative 1 times negative x leaves me with positive x. And negative 1 times positive 6 leaves me with negative 6. Okay, so that's how we distribute a negative 1. When you distribute a negative 1, really all you do is change the sign of each thing inside. Okay, because your 1 times x is just x, negative times a negative is a positive. 1 times 6 is 6, a negative times a positive is a negative. Okay, so we're going to look at this one because it's the one they show us horizontally. Nothing to distribute on the first linear expression, so that's good. Here we have, what are we distributing? Not a 2. We're distributing a negative 2, of course. So negative 2 times 4y is negative 8y. Negative 8y. Negative 2 times negative 3 is positive 6. So follow the sign rules and you'll be fine. The 7y plus 5 just came down. We didn't have to distribute anything. Now we can combine like terms. 7y and negative 8y leaves me with negative 1y, or you can just write that negative y because the 1 is unneeded. 5 and 6 is 11. So negative y plus 11. Well, that was fun. Let's give a couple of these a try. Okay, so number 5, you might look at this quickly and say there's nothing to distribute. That's incorrect. There is nothing to distribute out here because it's just a positive 1. But right here I have a negative 1. Remember, there's a 1 right here, and this time it's a negative 1, and we do have to distribute that. M minus 3 is not going to change, so that just stays M minus 3. Negative 1 times negative M, different sign, so positive 1 times M is M. Here I have negative 1 times positive 12. Negative times a positive is a negative, and 1 times 12 is 12. Well, now I can combine my like terms. I have an M and another M, both positive M, so 1M plus 1M is 2M. And I have a negative 3 and a negative 12. Same sign, add and keep. So I get 15, and it's a negative 15. So 2M minus 15. The next problem, it's got some decimals in it. Don't be afraid. But both of them have something to distribute this time. Negative 2 is what I'm distributing here. Negative 5 is what I'm distributing over here. Negative 2 times C is negative 2C. Negative 2 times a positive 2.5 will give me a negative, and 2 times 2.5 is 5. Negative 5 times 1.2C, I have a negative times a positive, so it gives me a negative answer. And 5 times 1.2 is 6, and then C, so 6C. A negative times a positive gives me a negative, and 5 times 4 is 20. All right, well, now I'll combine these. I've got a negative 2C and a negative 6C, which leaves me with a negative 8C. I've got a negative 5 and a negative 20. This is a really negative problem, isn't it? Negative 5 and negative 20, same sign, add and keep. Keep the negative, add the numbers. Negative 8C minus 25 is what you get when you subtract these linear expressions. When we're subtracting linear expressions, I really count it as we're adding linear expressions, but we just have to distribute that negative throughout the second expression.